All right, a couple free response log questions. On the morning of December 19th, a very special day, 5 zombies wander onto the Peak to Peak campus. They're hungry, but not ravished. Each zombie bites and affects a new person every 18 minutes. If this pattern continues, how long will it be until there are 1,280 zombies on campus? I'm going to show you how to do this problem in two different ways. I think the best way to do this problem is to think about the situation. So we are starting with what do we say? 5 zombies. So we have 5 zombies to start. So when t is 0, let's make a little table. T is 0, zombies are 5. Then if t is 18 minutes have passed, they each bite a new zombie. So now zombies are 10. And then if another 18 minutes pass, it's now 36 minutes, and now there are 20 zombies. And that pattern is going to continue forever and ever and ever. Each time we are multiplying by 2 from whatever number of zombies we have. So if we want the number of zombies with respect to time, z of t is going to equal that starting population of 5 times 2 to the power of t over 18. It's very similar to a half-life problem, except it's a doubling problem. The population isn't cut in half each time. The population doubles each time. So make sure this equation makes sense to you. If t were 18, that exponent would become 18 over 18. Thus, we are getting 1 as the exponent. And so we're taking 5 and multiplying it by 2 once to get 10. If time is 36, then 36 over 18 is 2, so our exponent is now 2, and so now we have 2 doublings. 5 times 2 is 10, times 2 is 20, etc., etc., etc. So we want to know how long until there are 1,280 zombies. So 1,280 equals 5 times 2 to the power of t over 18. And now we need to start solving things. Divide by 5. So 1,280 divided by 5 is 256. So 256 equals 2 to the power of t over 18. And if we want to get that t down, we need to log base 2 both sides. So log base 2 of 256 equals t over 18. So log base 2 of 256, you can count on your hands. 2, 4, 8, 16, 32, 64, 128, 256. I'm holding up 8 fingers, 1 for each number I said. So log base 2 of 256 is 8. So 8 equals t over 18. So then multiply by 18 on both sides. T equals 144 minutes until there are 1,280 zombies. Now, if you don't like coming up with equations for yourself, you could just use the poked model. Poked model being starting population 5 times e to some rate k times t, what would be a good time to choose? I would choose 18 because we know after 18 the number of zombies have doubled, so we'd equal 10 over there. In the same way that a half-life time would have half of the number over there. So now our first step would be to divide by 5. So 10 divided by 5 is 2 equals e to the k 18. And then natural log of 2 equals k times 18. And divide by 18, natural log of 2 over 18 equals k, our growth rate. In the same way that ln of 1/2 over the half-life equaled our our rate of decay, ln of 2 over the doubling time equals our rate of growth for a doubling problem. So find that value and store it in your calculator. And you get like 0.0385, but store it. I just sneezed like 15 times, so if I sound congested, that's why. I hate it. That number was roughly 0.038. But we need to store that as a variable. So store it as a. So once you calculate ln of 2 divided by 18, hit math, hit alpha math and then enter to store it as a variable a. We'll use that as a calculation. So I will call this a. So now what do we want to know? We want to know if the population is 1,280. what is the time. So keep writing your poked model. 5 times e to the power of k, our rate we just found, we're calling it a, times t. So now we just have to solve for t, which means 1280 divided by 5, we already said previously was 256, equals e to the a t, where a is our rate that we just found. So now ln both sides, ln of 256 equals a times t, where a is our rate again. So then last step, ln of 256 divided by a will tell us the time. And again, use that stored variable. And again, you get 144 for t. You get the exact same value if you just use the poked model, which I think is pretty cool. If you rounded that value to 0.039 instead of using the exact stored value, you would actually get 142.184 instead of 144 for the amount of time, which is not correct. So store your variables. Don't ever round in the middle of a problem. You are forcing yourself to get the wrong answer when you don't need to.